Okay, so hopefully you're here for another video. We are going through describing rigid transformations. So we had a concept video on rigid transformations, a skill video on describing translations. Now we're going to do another skill video, this time on describing reflections. Let's start it. All right, so as always, let's start by reading the question and seeing what it's asking us to do. The coordinate plane below shows how triangle ABC has been transformed to form triangle DEF. All right, describe the transformation that formed the image. Here's the question. Describe the transformation that formed the image. Okay, now let's reread this. At the top it says, the coordinate plane shows how triangle ABC has been transformed. Well, think about it. ABC has been transformed. That means ABC is my pre-image. I'm starting with ABC because that was transformed to form DEF. That will be my image. So on this first step, I now know that I need to describe the transformation that happened between these two triangles, and I've been able to identify the pre-image, ABC, because that one has been transformed to create or form triangle DEF, the image. So a pre-image is what we begin with, pre meaning before, and the image is the copy of the pre-image. Think about it as your phone. Take a picture with your phone, you see something in real life, that is our pre-image, you take a picture, now you have an image of it, you have a copy of it. Okay, let's go to step 2. Let's determine which transformation moved the figure. Is it a rotation, reflection, or translation? Well, looking at the triangle, this one's actually kind of tricky. I find it best to identify some sort of feature or point or side of the pre-image and then find the corresponding part, angle or side of the image and try to determine what happened. So let's see, maybe when I look at ABC, I kind of see it as maybe it kind of looks like this to me, that it's kind of pointing that way. I don't know, hopefully you see that it's looking that way to you, or you understand what I'm saying, that maybe here's a flat side and then it's pointing down to the left here. Okay, so now let's look at DEF. When I look at DEF above it, that flat side is here, so something has changed about that, and then it's now pointing up and to the left. Okay, so I've noticed that ABC was a triangle that maybe I could describe as pointing down and to the left, is now a triangle that is pointing up and to the left. Okay, so I'm going to rule out translation. I could not slide ABC straight up and overlap DEF. Those would not overlap. So that means it needs to be either a rotation or a reflection. Okay, well, let's first look to see if it was a reflection. If it was a reflection, the entire triangle would need to flip over a line of reflection. Okay, well, let's see. ABC and DEF, if I were to count this and kind of note right here, these are about 4 units apart. So let me see. We got 1, 2, 3, 4 units between these two triangles. Okay, so if it was a reflection, the line of reflection would have to be right in the middle between these two. Well, let's see, if here is right in the middle, that's right in the middle between the two shapes, was this a reflection? Well, I'm starting to think it is, but to be certain, we need to see, does every point reflect an equal distance across the line? So first off, point C reflected 2 units to get to the line and 2 units to the other side. Okay, so that's point C. Let's see if point A is the same distance from the line of reflection as point D. So let's just check. 1, 2, 3, 4, 5, 6, 7. It's 7 units. Now, if point D is 7 units away, I'm going to think this is probably a reflection. 1, 2, 3, 4, 5, 6, 7. Yes, it is 7 units away. So far, it looks like it has been flipped. Let's go ahead and check point B and E just to be safe. 1, 2, 3, 4, 5 units away from the line of reflection, and 1, 2, 3, 4, 5 units away from the line of reflection. I know that ABC was reflected across a line in order to form DEF. I know that because each point of ABC moved an equal distance across that line that I saw was right in between the shapes to know that it has been reflected. Now I'm going to erase all of this work. I'll leave it for a second if you want to see how I determined it was a reflection, because it's a little bit messy. And now that I know it's a reflection, I need to go on and figure out the details. So reflection, Again, we need to know the pre-image and the image. And I noticed that the line of reflection, this is our details here. What are the details? I noticed our line of reflection has to be directly between the two shapes. And I see that that is right here. Okay, so what do we call that line? What is that line's name? Well, luckily for us, it's on the x-axis. So that means it reflected across the x-axis. So this is the detail that we need for reflections. I can't just say it was flipped, or I can't just say it was a reflection. I need to say what it reflected across or over. So the line of reflection, I can spell, I promise. Line of reflection. Now, can I write neatly? Not so much. The line of reflection is the x-axis. Okay, if we wanted to write an equation for it, we would say it was y equals 0, but x-axis is perfect. Okay, so that's it. That's the details I need to describe a reflection. What was the line of reflection? In this case, it was the x-axis. So this is all my description we need to say. The transformation that formed ABC, oops, I forgot to change this from earlier, that formed DEF, the transformation that formed or made DEF was a reflection across the x-axis. Again, this being the key details we would need to include. You have to say that it was a reflection, and you have to say that it was across or over the x-axis. Okay, so if you haven't watched the other videos, there's a video on translations, and then there's also a video on rotations. If you're confused on what those are, watch the concept video on describing rigid transformations. All right, see you later.